scholars. Today we're going to talk about specific heat and heat transfer. And with that, this is under the same umbrella as thermodynamics, so some of this will be review. We're going to start by making sure we remember all about thermodynamics. So we talked about the first law of thermodynamics previously, a couple weeks ago, and the first law states that heat is conserved. Energy cannot be created nor destroyed. Then we talked about the second law, and the second law states that energy tends to disperse since the universe is in an increasing state of disorder. Then we talked about if energy is absorbed by substance, that means it's either warming up, melting, or boiling, versus energy being released, it is cooling down, condensing, or freezing. And this will be important as we continue to talk about heat today to remember the difference between energy absorption and energy being released. And then we talked about heat. Heat is the energy that is transferred. It is called heat. Heat always transfers from hot surfaces to surfaces lacking heat. And then once they're at that same temperature, they're said to be at thermal equilibrium. And then we'll talk a little bit more about heat transfer now, which some of this is new concepts. You may remember it from previous science classes, but on a whole, it is new. We can talk about system and surroundings, and these are different, and we need to understand what is our system that we're studying in order to best understand it. So the system is the process that we are focusing on, and then the surrounding is everything outside of the system. So for example, if I was focusing my studying on a campfire, that would be the system. Then the surroundings would be the dirt surrounding the campfire. It could be someone, a person is in the surrounding, or the rocks around the campfire could be part of the surrounding as well. We could be studying a water in beaker, and then the thermometer in the beaker of the water would be the surrounding. Or another system we could study is air inside a balloon. We've done that a lot the past couple weeks. But then the surrounding that we're not really studying right now is the air outside of the balloon. Next, we're going to transition to talk about specific heat, which is one of my favorite concepts because it is very applicable to things that you learn or that you experience in everyday life. So we'll jump right in. The definition of specific heat is the amount of energy required to change a 1 gram sample of a substance by 1 degree Celsius. So you might think about if you've ever been on a beach. In the middle of the day, the sand is really warm because sand has a really low specific heat. It's able to change the temperature really fast versus like at night, as soon as it has cooled off, the sand changes temperatures really fast and becomes cold really fast, and your feet might be cold. Versus other objects you might leave outside for a while, and it still doesn't change its temperature very much. So this picture we see over here, if we take a look, we see all of these substances, gold, silver, copper, water, etc., have been heated to the same degree, or to the same, they've been applied the same amount of heat. 1 gram of each of these materials, if you put 1 calorie worth of heat into it, the water only changes to like 1 degree, versus gold changes to 31 degrees Celsius and that when 1 calorie was applied to it. And that is because they have different specific heats. Some require more energy to change the 1 gram of sample to 1 degree Celsius, versus some require less. So for example, water is known to have a high specific heat capacity. Its value is 4.184 joules divided by grams times degrees Celsius. And we know that it requires it has a high specific heat capacity because it also takes a lot of energy to cool it down or heat it up. The equation for specific heat that you'll be learning today is called Q equals MCAT. You may have heard people say Q equals MCAT, and really what that is Q, which is heat, is equal to M, mass, and that should be the lowercase m. C is specific heat, and then delta T. So Q equals MC delta T, and delta T, of course, the delta symbol means change, and then T is temperature. So final minus initial temperature is delta T. So first, in order to use this equation, we need to know how to change temperatures. So practice with changing temperatures. A substance increases in temperature from 10 degrees Celsius to 80 degrees Celsius. What is the change in temperature? Well, delta T equals TF minus TI. So we ended, our final temperature was 80 degrees Celsius. Our initial temperature was 10 degrees Celsius. 80 minus 10 is 70 degrees Celsius. Next, a substance goes from 283 Kelvin to 353 Kelvin. What is the change in temperature? Well, our final temperature is 353. Our initial was 283 Kelvin. So this just so happens both of them were heating up. The change in temperature was positive 70 Kelvin. And it is not always positive. It could be negative as well if you're cooling down instead of warming up. Now we're going to look at the steps for using Q equals MCAT. So we have 4 steps to solve for them. First, we'll label everything in the problem, our Q, our M, our C, our delta T. We'll make sure that our units are consistent throughout. So in this class, we will always use joules, grams. We'll use the same units for C, and then delta T will always be in degrees Celsius. Then we'll plug and chug. And I actually like switching these steps. So if the unknown is delta T, we'll solve for that, and then we'll plug and chug. So our steps, our first question is, what is the specific heat of a substance that absorbs 2,500 joules of heat when a sample of 10,000 grams of the substance increases from 10 degrees Celsius to 70 degrees Celsius? Well, first we wanted to make sure we had all of those steps written down. Next, we are going to label everything in our problem. So our Q is equal to 2,500 joules because heat, it's absorbing that much heat. Our mass is 10,000 grams because it's that much of the substance. Our C is what we're trying to find because it asks for a specific heat. Then our change in T we have to find. We have our TF was 70 degrees Celsius and our TI was 10 degrees Celsius. We make sure our units are consistent. These are perfect because we wanted joules, grams, degrees Celsius, because our specific heat will be in joules divided by grams times degrees Celsius as well. Next, we need to solve for our delta T. So we decide from the reading, is our temperature heating up or cooling down? It's heating up, so we know that it will be a positive temperature change, and we calculated that to be 60 degrees Celsius. Next, we plug and chug. So we use Q equals MCAT, and like I said earlier, you always want to use your parentheses. So 2,500 joules equals 10,000 grams, parentheses C, parentheses 60 degrees Celsius. I like rewriting it without units. I think it is easier to follow than if you use parentheses. You also could have isolated C like you did in physics and use the equation C equals Q divided by M times delta T instead. That would work also. But here we just do our algebra just like we did for the ideal gas law last week. And then we found that C equals 0.00417. I remember, okay, C is specific heat. The units for our specific heat are joules divided by grams times degrees Celsius. So that is my final answer. We have another example, so pause the video and solve for this problem here. So I labeled all of my work and went through, used parentheses as I was solving for my work. I isolated M to get it by itself and found that M is 79.7 grams. And that is my final answer. We have 3 practice problems for you to complete for homework tonight. Please make sure to show all of your work in these questions. And then if you have any questions, bring them to class next class, but you will not get all your credit if you don't show your work, so make sure you show your work and you have all of your notes filled out. If you need anything, email your teacher or ask next class. Have a wonderful day.